picking it up where we left off, and I need to cancel here, simplify the problem that multiplies through your thought. I cancel the things that are in the diagonal instead of the center. You notice I have two A's that go bye-bye right away. I also notice that the 20 and the 32 have a 4 in common. So I go ahead and I divide that out, and I'm left with 5, and I'm left with 8 up here. Now, I just have negative 7 times 8 gives me negative 56, 15b. Because there's nothing else in common that I cancel in my cross areas. And that's my final answer for that one. Now the next one, before I go ahead and solve this linear equation, I notice I have some like terms I can combine right there before I start moving anything. So I'm going to go ahead and do 4z minus 2z to get 2z plus 29 equals 25. Now I'm just going to minus the 29 on both sides, and I'm left with 2z is equal to negative 4. Now I divide, and I'm left with z is equal to negative 2. That is my final answer. Now the next one I'm going to look at is solving an inequality. And we haven't seen one of these before. So I'm going to talk to you about how to solve it, and then how to plot it, and shade, and how to write it in interval notation. So let's go ahead and solve this first. So I can just go ahead and add the 2 onto this side. And I'm going to finish it up here. I have 2z is greater than or equal to 3. And I divide by 2. And so I'm left with z is greater than or equal to 3 over 2. Now, when it comes to having the symbols like this or like this, your teachers might have talked to you about using brackets and or a solid dot to show that. If you have the open with no line underneath it, then you would use open parentheses or an open circle to denote it. So I'm going to use the circle because that's what many students were telling me that they were doing. So if you look here, this 3 over 2 is 1 1/2. So if I look at my graph, 1 1/2 falls in here somewhere, and it's a closed circle, so I do it as best as I can about there. Now I need shade. So if you notice here, this is saying z is greater than or equal. So all the positive z's bigger than 3 1/2, they go on forever to infinity. Another trick, and this only works if your variable is on the left-hand side, only at the left-hand side, not on the right-hand side. If you notice, I have z is greater than or equal to. Notice how the arrow is pointing. Notice how that arrow is pointing. You want to shade in that direction. That will always work if it is on, your variable is on the left-hand side, not on the right-hand side, but the left-hand side. Now that I've done my shading, I can do my interval notation. So this is telling me this starts at 3 over 2, and it's got the underline, so I'm going to use a bracket. It goes on forever to infinity. So my notation would be 3 over 2 with the bracket, comma, infinity, and all the infinities only have an open parenthesis. They never have a bracket. Even with negative infinity, you will not have a bracket. So if your teacher says they want you to graph, they want you to solve it, and they want it in interval notation, this right here that I just circled in blue is the interval notation that we're talking about. Now, let's look at these three set of problems, okay? The first one is saying put this in this word, like sentence here, that they're explaining into a math problem. Let's do this. Let's get some number. Some number is x, okay? It says minus negative 11, so minus negative 11, I'm just using parentheses, you don't have to, is equal, so equal sign, to the number, so that's x, times 2. Now, you want to write 2x and not x2. That's not going to look right, okay? I'm going to do it like that. I want to know what is the number. So now it's time to solve it. Let's take it over here. I'm going to go ahead and simplify that minus negative and make it 11 plus 11 is equal to 2x. Now I just minus the x over here, minus the x over here, and 11 plus 11 is equal to x. So I solved it. That's my answer. Now this next one says solve for a. And a lot of people get thrown off with these types of problems because they're sitting here going, well, I'm used to doing what we did in the last example, subtracting and adding, but then I actually put those things together, like I minus my x and I subtracted it from 2x. But here we're going to do that, but we're not actually going to combine it. There's no way I can combine b and c with b. So I'm going to subtract it. I'm just going to rewrite it. I'm going to minus the b, and I'm going to minus the c, and it's going to cancel over here. I'm going to do it it over here as well. But I can't put them with the p, so it's going to be p minus b minus c is equal to a. It's the same thing, but I'm not corresponding. Let's talk about these consecutive integer problems. They really throw people off because they're not that easy to do. So they tell me that the sum, so I'm adding, of 3 consecutive integers is 75. So it's equal to 75. 3 consecutive integers are integers that are next to each other. That's what consecutive means. So if you look at like 1, 2, 3, 4, 5, 6, 11, 12, 13. They're all next to each other. So if I use a variable to represent 1, let's say x. And how do I go from 1 to 2 mathematically? With addition, not with multiplication. So to go from 1 to 2, I add 1. Okay? So the 2 is represented by x plus 1. That's always the case. Now to go from 1 to 3, I add 2, right? So I'm going from 1 to 3. I'm not going from 2 to 3. So now 3 is represented by x plus 2. These, right here, are what you would always use to represent the sum of 3 consecutive integers, or 3 consecutive integers. So what you have to do is to do this as a sum, add them up. You have x plus 1. A lot of people put parentheses around them. It's not required. Plus x plus 2 is equal to 75. Now I'm just going to solve this problem. I had someone at the review ask me, what we're going to see next is whenever I combine my like terms, what happens? So I have 3x's, 3x, and I have 1 and 2, which gives me plus 3. And they said, well, wait a minute, 3x plus 3. If I'm doing this up with 4 consecutive integers, would that be 4x plus 4? And no, it wouldn't. So don't automatically think that if your teacher puts that on the test. It's a trick, okay? It's not going to be that. Don't just think I'm going to shortcut this and go on. Before I move on to solving this, if I did have a 4th consecutive integer, well, how would I get from 1 to 4? Just to show you, I would add 3. So 4 would be x plus 3. Now, if you look here, I do it 4x's with all 4 of these, okay? But I have 1, 2, and 3. If I add those up, I end up with 6 and not 4. I'm just pointing that out to you that if you had to keep going more, you would just increase every time by x plus the next number up, okay? Now, back to this. Let's go ahead and solve. So now this is a regular algebra problem. I minus 3. And I get 3x is equal to 72. And I divide by 3.